welcome to the session. Welcome to the India Cloud Security Summit, which is running for the whole day. And you have multiple sessions across different track on cloud, security, M365 and Power Platforms. Thanks to the organizers and the sponsors. And I just go on to the next slide. Yep. Just want to give you a highlight. There is an quiz program running as part of this session across the whole day. I think just keep a watch out, and there are some exciting prizes. Let's go on to the session. So my session is about Azure networking services, which can adopt for you to do a zero trust on the cloud security. And I'm Santosh Kumar Anandakrishnan. My name is Solenti. I'm cloud and cybersecurity architect, and I hold Azure MEP on networking and security. And this is my second year. Before I go, I would like to congratulate all my organizing the other fellow MEPs who just got renewed on yesterday. Since this yesterday is our renewal day, just want to thank them as well. And just about background on me, could call me Santosh. I am currently in Melbourne, in Australia, but natively back to Tamil Nadu and Chennai. And I hold my MEP for Azure networking and the cloud security. And my focus is mostly on infra. My skill set belongs to the infrastructure from anything on the cloud, data center, private endpoints, and the security. And other than my technical skills, you can find me in cricket ground. And I have my blogging. I just grab a link of this and I'll do some blog around the cloud, Azure, and the cloud security. Before I go on, just quickly to go through my agenda list today is just want to set the narrative for the zero trust principles and how the Azure networking services can fit into the zero trust one and what is the best practices to be encaptured for this. And lastly, we touch on Azure networking services under the protect and delivery of application cloud security. And the last one will be the continuous monitoring. Okay, before I go on to something on technical, I just want to show you some security stats. It's not so scary. I just want to put word something to be cautious there. And my second slide will give you that information. Like cyber threats are rapidly escalating, and it's been more sophisticated with the AI has been happening across the side. On the fence, it's both the defenders as well as the attackers are consuming AI now. So if you just look at the slide right on 2023, this is the statistics come from Microsoft. So 2023, Microsoft were able to track their threat attackers on the numbers around 300. If you look at 2024, it is 5 times been increasing. That shows the volume of cyber attacks happening across the world, and the speed is as well just getting faster, and attackers can compromise the data and getting into the access of the sensitive informations. And the scale as well, like it's happening, and the number of password attacks per second has been skyrocketed from 579 to 7,000 plus odd. On the conclusion side, attackers are now more sophisticated and faster and occurring at massive scale. That leads to adapt a strategy, and that's where it comes on zero trust. On the other side, if you look at the numbers and stats, passwords remain the primary attack on the vector side. The passwords are the weakest link. In other way, other options are 84% of attacks are involved on internet exposure. The devices, the application services which is being exposed towards the internet, and if it's not protected with the proper way of the application design or the consumption of security, then it's being exposed to internet side. And the second one is the identity. That's just a basic statistics to just let know people what's happening on the globe. We'll move on to the agenda stuff. Why zero trust? In the today's organizations, right, the need of a new security model that where the more effectively adapts the complexity of the modern environment, like which has been the hybrid workplace, work from anywhere, digital adaptation and digital modernization, all these things are going up. That's where the security focus has been getting as a priority way. If you look up probably in 5-10 years ago, how the organizations has started their security model is where they have a flat network. It will be mostly wide and open and flat networks, and they'll have some security perimeters with a firewall, with some IDPs and stuff, and there will be very minimal threat protections. And mostly, what is everyone's on the mind is like anything behind the firewall is protected. That's not the world now it's been. The reason, as mentioned earlier, right, the zero trust, why the zero trust is required is you want to have the productivity be anywhere. Now the organizations has multiple regions, empowering the users to work from anywhere. Even the COVID time, what happened is you can work from anywhere. That's the reality. The users need to more securely access the data and anytime from any device. Need not to be there within the corporate way. And the second thing is the cloud migration, where the digital transformation takes the world into the intelligent security for the today's complex environment. The last one is to minimize the risk mitigation. Close the security gaps and minimize the risk for the lateral movement. When I say the lateral movement is when some devices got affected, you want to restrict that devices within a secure perimeter, not to be carried out to the other network security areas. So you want to just contain that space. In the face of AI-driven digital growth, the threat landscape that never sleeps actually. That's when we need to adapt this Azure networking services can be help you to adapt your zero trust. Zero trust is not a service or a product by default. It is a security strategy that needs to be designed and implementing the security principles and guardrails for the entire organizations, even it's been cloud or on-prem. Okay, zero trust. What does it means for the end user? The zero trust has three basic principles: verify explicitly. Second one is user least privilege access, and third one is assume the breach. What does a zero trust gives to the organization and end user is it assumes that cyber attacks can happen at anywhere inside the organization. It can be outside on the internet. This means that we need to verify and we're not required to trust any devices which is within the network or it from internet. That gives that option to be making sure the first principle, verify explicitly. No user or device is trusted by default. Even though they are from within the organization or from the internet, don't trust any device and user. Just make sure you're verify explicitly authenticated or authorized. The second one is least privilege access. By the word says that its user systems needs to have the minimal required permissions to perform their role of activity on the systems or in the applications. The third one is assume the breach. Always operate as if the network is already compromised. You want to make sure the data breach is not happening across your network. Want to just contaminate within the smallest area. What is a zero trust security benefit brings up? I'm just highlighting that four consolidated way. The enhanced security. The zero trust reduce the attack surface. We want to minimize the breach of impact. And that way, every access or request comes into the organization, regardless of where it comes from, you have to be authenticated. And third one is the compliance level, where organization needs to meet certain regulatory compliances based on the geographical location. It can be GDPR, it can be NIST, it can be ISM control, all those things. So, which helps to meet that regulations by enforcing a strict data protection policies and all the security controls and policies required. The third one is increased agility, making sure the users can be work from remote, it can be flexible access, enabling the users to work from anywhere without compromising the data and the security. The last one is to minimize the data loss and security and incidents. Given that I spoke about zero trust on highly on the technical side, I just want to paint a picture to make sure what I'm speaking up to just make relevance to everyone. So let's take an example on how do we picture that into zero trust. A common example I want to tell you is like taking any building or anything like a museum or library. Let's assume as a museum, assume as a library. How does zero trust works in that way with the three principles? The first principle is never trust, always verify. Imagine you are a librarian. In the olden days, you trusted anyone who walked into the door of the building, assumed that they were ready to here to read the book or use the computer. But in the zero trust model, you treat every person as a stranger. And even if they're holding a library card before letting them access the resources, you always verify their identity, make sure they are the authenticate person to get into that area. That's where the first policy of never trust, always verify works in that way. The second one is the least privilege, similar to the library stuff. Think about how library members have different level of access, like the children will have access to the books and comics, the researcher or anyone on advanced technology, something, they will have access to the different areas of permissions to access the old archives or something. You don't need to give everyone the keys of every section. It is just a part they just need in. Wherever they want, you have to make sure what access is needed on what ways. That's it. And the last one is assume the breach. Even though you trust your library and its members, right, you always be cautious and make sure you have the required technologies to restrict the action section, I mean, restrict the access for the specific section or misuse of any of the misuse will be happening. How do we control it? How do we monitor it? That's where this assume the breach, the third principle comes in. Maybe you can just use a surveillance camera. You just want to make sure the librarian checks in so each user and where it goes and all those things. That's how it works actually. So I just want to give you a high level with a non-technology term just to picture it that way, that how this zero trust works in that way. Okay, let's get into the core now. The Azure networking services is vast services in Azure, where a lot of services are part of networking. We just picture that into four different pillars. First one is connect. As the name replicates that, you will have the connectivity services like Azure Virtual Network, which is your foundation of the building blocks in the Azure cloud. And you can have your connectivity like virtual WAN or Express Route or VPN to make sure you secure connection back to the different locations, or it can be an on-premise, or it can be a remote access connection required. The second part of the pillar of networking services is protection, where it gives you productivity to across your workloads like the DDoS protection, Azure WAF, Azure Firewall, NSG, and service endpoints. As part of today's slide, I'll be speaking more about the product and delivery side. So I'll just give you high level here, and in the coming up slides, we'll just speak a bit more. On the delivery, the third pillar, where it just delivers the application and the services to the end user with the protection and how it is going to be accessed across the globe or wherever they belongs to. That's where the services like Azure Friend Door, which is a CDN, Traffic Manager, and Application Gateway and Load Balancer comes in. And the last part, which is not the least one, that's a monitoring, is always need to enable your diagnostics and logs and monitoring to be captured so that if there is a need for you to do and troubleshoot your resources, anything on connectivity, anything on the virtual network or networking services, that's always required. Let's go into the protection or Azure networking product services. Like as I mentioned, the virtual network forms the basic foundation for any workloads or services to be created as part of in the Azure cloud. What happens in network topology, right? As you might know that there are two different topologies available in Azure. One is the traditional hub and spoke. The second one is the virtual WAN, which has been the newly evolving methodology. There is not purely recommended way to both on these options, but I would suggest to just start with traditional way, the hub and spoke, so that you can just translate back when there is a need for you to go on virtual WAN. So the traditional hub and spoke will have your centralized connectivity, and you place all your firewalls and networking securities, everything on the centralized way. So anything from one virtual network to another virtual network, you always make sure you verify the explicitly. That's where the principle number one works out. Verify and make sure you are authenticated. Make sure the traffic from the spoke one goes to spoke two needs to be verified in the firewall in between to make sure you intercept the traffic and making sure it's been allowed. And in that way, you are keeping two different spokes so that you are making sure that anything happens on the spoke one is not being transmitted to the spoke two. So that way you are performing that assume the breach, the principles as well. In addition to this, virtual networks and the firewalls, which we'll speak about in the next slide, there is something called NSG. That's Network Security Group, which intercepts your filtering traffic between inbound and outbound within the virtual network. So by default in NSG, what happens is there is an allow happens on that way. So the first thing what you do is when you're creating on organization level, like for enterprise level, you have to just create a block anything. And you specifically allow, which is required as part of the application or the workloads. It'll be more complex when you have multiple workloads within the virtual network and NSG. That's where the application security groups comes in, which simplifies the NSG rule management. So just imagine you have three-tier application, web app and DB. And if there is a new workload comes in, you have to specifically pin in your IP address of the workloads into that NSG level. But what happens in ASG is you just specify that the workloads within web app DB, and you have the specific rules explicitly allowed only from web to app and app to DB. So in that way, if there is a change in the workload or anything happens in the workload, right, just it automatically adds in that way. So application security group that way makes life simple for the operation and day-to-day life. The next slide speaks about the private endpoints. If you want to have an Azure PaaS or publicly platform as a service which we created, by default, the public endpoints are the shared instance of Azure services that is accessible via the public networks. What happens in that way is it'll be pretty easy to create and it can be accessible. But if you look at in this zero trust model, right, it is exposing the services to the broader internet, which can prevent it can present the security risk. So to take it out from that on a zero trust model, you have to pin in as a private endpoint. When you enable a private endpoint, the pass becomes as a endpoint's professional path for accessing your resources of anything within Azure within the virtual network. What happens is it becomes as a part of your virtual network. It's a private way. So you have a private IP address for the pass, and all the public access has been taken out. So you can restrict the access with the NSG, and all the way you can just make it more secure between the required source to the destination of the pass. If you don't have a private endpoints, there are few services where you may not be able to available to use a private endpoint. Then there is an option for VNet service injection. It's similar to the private endpoint, but you can just need to have your own dedicated subnet or something to be scoped out, and that way you can just secure the private endpoint. I mean, the secure the PaaS services. This is the main one, the Azure Firewall. The Azure Firewall is a cloud native service which been given up for you to protect your inbound and outbound traffic. It can be east-west, it can be north-south. When I say east-west, the traffic between one VNet to other VNet or spoke to spoke, that has to travel to the firewall to make sure the spoke one workload has been authenticated to make the traffic back to the spoke two. Or it can be a north southbound where it can be going to internet or going back to a different on-premise or the VPN connection. You're making sure every traffic which hits out of your network is being captured and it's being intercepted actually. I'm just giving an example here as a firewall, Azure firewall, but there are other options in Azure where you can have bring your own firewall or a service provider, which you have it in on-prem. It can be Palo, it can be an F5, whatever it can be. That can be supported as well. And what happens with the firewall is Azure Firewall comes up with the three SKUs, which it starts with the premium, standard, and the basic one. But it's always recommended to use the premium one, which gives an ideal way of securing the high-level sensitive application or anything on your workloads. And it provides some additional threat protection features like malware, TLS inspection, and making sure SSL can be decrypted and encrypted as well. So in that way, you just making sure your always verify principle as well as the second principle least privileges being encaptured with the firewall settings. The last slide in Azure Protection Services is DDoS protection. As the name replicates, the distributed denial of service is designed to define your Azure services from the large scale, and there is a option for it is it has I can say three premium versions, three different SKUs are available. The first one is the infrastructure protection, which comes by default to everyone available with no additional cost, and that's applicable only at the infrastructure level. When you go to the workload and the application level, then you have to specifically create a DDoS protection for the network protection or the IP protection. There is a premium cost added to it, but what happens is you can utilize there is a specific team, a dedicated team in the backend works on the Azure side where they just monitors all your traffic which is being captured, and it uses Azure machine learning to detect and mitigate the attacks without any manual intervention. So what happens is the traffic is continuously monitoring for irregular patterns and mitigation is applied seamlessly. So in that way, you'll have a dedicated team in the backend. If there is a support required, you can just directly speak to them and just get what's happening in the backend. How do we protect that way? So that way it's a premium cost, but it gives some additional flexibility for the customer. With this slide, we are concluding on Azure Protect services. Now we'll move into the delivery side of application to the external world. Say if you have an application services which you will be hosting in, and it can be a PaaS or it can be VMs. The best general way it is don't expose directly your source into the internet for an exposure. As part of the slide, I showed you that 68% of the internet attacks happens on the device or the application which has been exposed direct to the public. So the best way to take it out is use a load balancer layer 7 application services, which is like Azure Application Gateway or the friend or the traffic manager, which we're going to discuss in a couple of slides now. That's always best recommended to keep them as a friend and making sure you are safeguarding your resources in the back end. Azure Application Gateway, it's a layer 7 load balancer, web-based traffic. What does it provide? It provides you a SSL termination, and it just comes with an high availability and zone redundancy, and can be auto scalable as well. It supports both even for the internal application as well as the publicly available applications. And the backend VMs can be anything like VM scale set. It can be load balancer or it can be a PaaS services as well. And if you are specifically looking about cloud native applications like Azure Kubernetes and container services, then there is a different version within Azure Application Gateway. It's called Azure Application Gateway for Containers. It similarly does the same thing, but it works out in the ingress and the ingress level. So if it will speaks into the cloud native level of resourcing that way. So if you're focusing on the cloud native, then I would recommend you to look out Azure Application Gateway for Containers as an option. On the security side, what happens is it just provides centralized SSL offload. It can integrate with web application firewall, that's a WAF. I'll speak about WAF in the next coming slide, so we can just discuss about what is WAF. And Azure Application Gateways comes with two different SKUs, as all services has different options. So it's recommended to go with version 2. The version was getting retired sooner. So SSL and TLS termination is way the application gateway supports, so that anything comes on a publicly available to application, it allows the unencrypted traffic to be it allows unencrypted traffic to the backend service. So it just stops that way so that it doesn't makes the backend services being more bombarded in that way. Um, I'm just whatever I spoke on the services and the security features, right? That's just listing out here. It supports in the WAF for the DDoS protection. So in the DDoS protection, right, if you have WAF and DDoS enabled, then it just covers up from layer 4 to layer 7. It just combines all your protection for the application. And in addition, all these bot managers and AI rules can be comes in the automated way, and you can just use it as part of it. And private link is available so that making sure anything is not publicly exposable, it just everything goes in the private only mode. And the traffic management, you can do redirection, URI path routing, host address routing. All these features has been available for the traffic management. The different version of the next services as part of this is Azure Front Door. Before I go, what I want to say here between these two different services, right? Azure Application Gateway and the Front Door. Azure Application Gateway is a regional based service. So let's imagine you have an backend services on primary region as India and second region as Singapore in Azure region. If you have an application gateway, you have to create two different application gateway, one in India region and one is the Singapore region. So if the one region backend service goes down, the traffic is not automatically redirected to the secondary because you have to do the manual DNS change in the application gateway. To overcome this, we have a service called Azure Front Door. What happens is Azure Front Door is a global service. It is a global traffic distribution and optimization of application delivery. So in the same scenario, what I spoke earlier, if you have two different primary and second region, and if you have front door, if the service A in the region A goes down, it automatically redirects the traffic back to the service B. So that is automated way it works out in Azure Front Door. That's a major difference between Azure Front Door and Application Gateway. In addition to that, Azure Front Door provides you the CDN, the Content Delivery Network. It caches the information and has it in the edge location. As soon as someone requesting on the web, it just provides the cloud content from CDN that delivers and provides fast and reliable secure information. That's a two difference between Azure Application Gateway and to the Front Door. And both Azure Application Gateway and the Front Door both can be combined with WAF. And there is a third service to be protected is Traffic Manager. The main difference between Traffic Manager and the Azure Front Door, it works similarly like health checks, performs the primary is down, it just redirects in the secondary. That's all perfectly fine. Only thing is it's not CDN. It is a DNS-based traffic load balancer that it distributes the traffic to the backend application endpoints and improving the availability, making sure it's automatically translated from the primary region to secondary region if there is a disaster or some services down. It just provides a DNS-based load balancing and global distribution and high availability, and it can provide you improved performance. The only service is lacking here is CDN when you compare with the Azure Front Door. These are the three different services mainly can be used to making sure application is not explicitly exposed to public by keeping all your services in the back end to this actually. And in Azure Front Door and Application Gateway, you can make sure everything is connected via the private endpoint so that the traffic between your application gateway and your backend is purely coming on Azure Virtual Network in the backend. So one more point I want to stress here is that ingress and egress, right? When you have applications and been exposed to internet, you have to make sure your application delivery services like Azure Application Gateway or Front or a Traffic Manager based on your requirement is being put up into Front, and that provides you the much better application security in that way. And you can integrate all this Azure Application Gateway and Front Door can be work in parallel with your Azure firewall or any other firewall. So you can keep your ingress comes into the WAF in the front door, then it makes sure your traffic is hits the firewall and it comes back to the backend resources. So that way you are just making sure even you expose that into the front door, you're making sure your traffic is hits to legitimate and it just connects back to the backend with the proper validation of the principle of always verify and making sure that assume the breach has been taken care. I spoke about WAF in a couple of slides earlier, like as the name simplifies that web application firewall. It just protects the applications on the web attacks. It protects like cross-site scripting, SQL injection, and it blocks the threads on based on WhatsApp rule set. It can comes with the default with the rule set, and it provides an option for you to customize it and want to tweak the things based on your specific application requirement. Yes, that can be worked out. WAF will be sitting along with application gateway and the front door to make sure your layer 7 application on the layer 7 is being taken care with the protection of application side. And these logs can be integrated with your Azure Monitor, and all these threads can be connected back to the Azure Defender or Azure Security Center the older way. This is a kind of a choice salary. What I spoke earlier, right? Like traffic manager, application gateway, friend door, in combination of WAF. How do I choose based on my application? This is a workflow where you can just start in the decision tree. Say, for example, if you look at, let me bring my laser here. If you look at start here, you're looking for a global web balanced application is being created as part of different region. And if it is yes, you just go for SSL offloading. It needs to be required. Then if it is yes, you just go for, do you want to have a CDN? You want to have a content delivery from application across the globe. If it's yes, then option for you is available is Azure Friend Door plus application gateway for different regions. If you don't want to do global L balancing and if you don't want to do SSL offloading, then the basic thing is works out is application gateway. And if you want to do SSL offloading and without CDN, then it's a traffic manager. So this provides you a decision tree to work with your requirement and pick up in choice of your selection of services. So what we spoke so far is zero trust principles, how Azure networking services on the protect and delivery can be used to protect your application security and making sure it's been aligned to the zero trust principles. I have the next couple of slides which will speak about how it can be implemented into the organizations on the Azure cloud security level. As I said, the network topology has two different versions, hub and spoke and virtual WAN. What I'm calling it here is a hub net, but it can be virtual WAN as well. But this is applicable to the both topology. To implement zero trust principle, making sure you have firewall is being captured. Since I'm calling it Azure Firewall here, we are calling it as a premium, which has the TLS inspection and all this advanced features, threat protection, everything comes out of that premium. If you have something else as part of your organization, then make sure your firewall has been has been implemented in the Azure Hub VNet or the core connectivity subscription. Sorry. So that's the first priority. And second thing is making sure you're deploying a DDoS protection. That way, you are just verifying it. Your traffic application comes in part of your entire application has been secured. And the third way is making sure you're configuring your required gateway routing. So what happens in that way is when a spoke from one application which sits in the spoke one to the another spoke one to speak up or traffic has to hit up, it has to go through the Azure firewall, making sure your traffic is legitimate and it's been allowed in the traffic. And the last one is configure the threat protection. Sorry, guys. That's a Microsoft Defender for cloud. You want to make sure your threat protection alerts has been captured as part of your entire Azure security. So in that way, we're just capturing verify explicitly by making sure Azure firewall inspect the traffic and the DDoS and just in provide comes. Sorry, guys. Sorry. Let's go to the next slide. This speaks about enhancing your Azure networking security with zero trust for the spoke VNet. What we spoke in the earlier slide speaks about the hub. How do you protect your hub, making sure your firewall sits in, all the traffic comes from the spoke has been captured there. On the spoke side, you have to make sure your RBAC has been set up. Isolate your required resource into a specific resource group so that you can provide RBAC based on that. And make sure your virtual network as part of a spoke has been captured into a different subnet, making sure you have the network segmentation for each of your applications. And applicably, you have to create NSG and ASG to control your applications. And the next one will be enabling threat protection and making sure the traffic has been secure. Access to the VNet application is enabled via the layer 7, like Azure Application Gateway or Azure Front Door, which sits in front of your application, making sure everything has been secured, and you'll have the threat protection enabled for your application services. The next slide speaks about how do you have an spoke VNet, which has been part of your PaaS. The only difference between the earlier slide and this slide is if you have a PaaS version of it, making sure you have a private endpoint has been created. The PaaS is not exposed. Doesn't have exposure towards the public anyway. It's not having direct access to the public, making sure everything is being created as part of private endpoint. And when you want to secure your ingress and egress, as application delivery comes in, like a layer 7 load balancer, front door, application gateway, that helps you to protect your services from all the threat protection as part of a layer 7 advanced. In addition to that, enable your threat protection, alerting, and monitoring, which comes as default to making sure everything is captured. So that way, when you get into troubleshoot mode, you have access to all your required logs to making sure what has been made and cost for us. So this way, we are making sure the zero trust principles of verify explicitly comes in. You have to make sure your threat protection has been used, your firewall has been used, and the second principle of leveraging the least access principle, making sure RBAC has been applied for you, the custom roles or the networking resources. And the last one is assume the breach, making sure you have the network segmented so that you let's just have that legitimate lateral movement is being stopped from one area to other area. This is the kind of a diagram which gives you a references way what we spoke earlier. So far in the zero trust way. So if you look at here, this on the left hand side is the internet where it's been outside of your Azure, or it can be on-prem or your data center here in the below. And you have the hub virtual network sits here, where your firewall and your bastion and connectivity of the gateway subnet, everything sits there. So any traffic comes in from internet or from anywhere outside of your Azure cloud, it hits your firewall first and make sure the legitimate traffic is been have access back to this required spoke. It can be front tier, app tier, and with the data tier. All the traffic hosted by the firewall. And if you look at an Azure application way, any application is exposed into an internet that has to capture it via the WAF firewall plus the application gateway, or it can be a front door as well. If it's two different region, recommended to go into front door. So this is just a reference diagram, how it works out, what we spoke earlier, and what are things has to be set up as part of adapting towards Azure Trust for Azure networking services. As I said, right, zero trust is not just service or product which you can buy and just implement. It has to be a strategy of security strategy which has to be adapted for the entire organization. How do we start that? The initial deployment objective, and I call it as additional deployment objective. We start with something to start with initially, have a network segmentation like how is my network is going to be segmented. Like I need to have my own segmentation for my application and workloads, and how do I connect back to my on premises, or it can be a different region, hub to spoke, hub and spoke topology, or it can be v1. Just make sure how your network segmentation has to be there. That's the first principle. That's the first step, I would say. The second thing is how do I protect that? How do I make sure my threat protection is enabled? It can be Defender for cloud, Defender for servers and endpoint protection. All those things comes as a part of the threat protection. And the third thing is encryption. Make sure the application traffic has been encrypted and it's been decrypted in the firewall to make sure the traffic is legitimate. These are the three basic steps has to be taken care. Once you have been comfortable in implementing that across your organization, the next step is additional deployment objects. Like I call it as advanced way. When you want to make it as a network segmentation, just go into the micro level. Don't go deeper into the micro level, then it will be too complex for you to set up that way. I would recommend at least to go in the micro segmentation instead of macro segmentation, making sure everything is as segmented and it's been captured in its own workloads and specific way. The threat protection, go for something with additional AI and machine learning adapted threat protection like Microsoft Defender for Cloud, which comes out with different plan for servers, database, and Key Vault, all those resources. So just go and enable that for entire resources and tenants. So that way you just get all the security alerts which has been needed for you to make sure it's been addressed across your tenant level. On the encryption level, make sure it's been even the internal traffic, not only the publicly exposed, even the internal traffic has to be encrypted. The last best part is discontinue the legacy technology. As Azure or any cloud, right? It's just getting evolved every day. And every day, your new services getting adapted, and some of the existing or the old services getting decommissioned. It has to go on legacy way. So you have to make sure you're not using anything on the legacy technology, so that way you are keeping everything is updated into the latest world. And the last one is monitoring. The unified security operation, that's a new way of security operation center as part of coming as part of cloud security in general availability. It's currently in GA now. Microsoft Unified Security Operation Platform, which delivers unified threat protection, extended detection response, and SIEM, and so everything comes into one single thing. I think the security portal is going to be the massive way for AI, artificial intelligence powered SOC. So once you enable all the required log and monitoring of security enabling controls, right, everything will be captured in one single place, and that will be calling as Unified Security Operation Platform. The Microsoft Defender portal is going to be the one single source of truth for security. That way, it provides unified security operation that can integrate like SIEM, like Sentinel, log analytics workspace, and security alerts and everything on anything on the Defender. It can be both on M365 as well as Azure. So it just gives you one single pane of glass for your monitoring and management, and that way it just gives you the posture and exposure management and cloud security and threat intelligence. I think we are kind of closing here with the last slide here. Whatever we spoke now, it's all about how do we adapt your Azure Zero Trust for your Azure cloud security. The three principles: never trust, always verify, and the least privilege access and the assume breach. On the never trust and verify, you can use Azure Firewall and make sure your Bastion and Enter ID has been integrated that to make sure you're always authenticated and authorized for any user logs in. And the least privilege access is making sure you have an airbag, you have an NSG, and you have to make sure just in time has been enabled, and you make sure all your application has been enabled with application gateway or a layer 7 load balancer like Friend or a traffic manager combined with WAF. And the last principle is assume the breach, making sure you have required logs in Azure Sentinel, DDoS protection is enabled, and Azure Traffic Manager or the Network Watcher has been enabled. So in that way, you just capture all these things required as part of your diagnostics or going back into look of what has been happened. The other thing I want to summarize is just start with secure by design. When I say secure by design, you have to incorporate that threat modeling and risk assessment as the earliest in the planning phase, and make sure your secure is by default and secure operations center something to be capturing all your logs in one way and monitor it. And that way you can just making sure anything goes out of your way, you can have control of it. I think that summarizes my slides. I'll open for any questions or anything to be raised up. Happy to answer. I don't have any demo here because, as I said, security zero trust is not a product or service. It's just been adaptation of a strategy. Bruce, I think I'm done. If there is any no questions,
Yeah,
then I'm.
Sudarsh, I'm just seeing if there are any questions from the learners. We
Yeah,
have
I
another
see.
5 minutes.
Yep,
Yeah.
I see there is a question of what are the key limitations of Azure Firewall? Does it offer malware sandboxing and keep function inspection? Can Azure Firewall handle environments with large scale output? Yes, it's a good question. Azure Firewall has, if you want to use it for a sandboxing, just to keep it your for you want to make sure it's a POC or testing, yes, you can go with Azure Firewall with the basics queue, where you can just test it with all your requirement. But what I will say is when you go with the basics queue, you'll be missing all the advanced features like TLS inspection, malware scanning, all those things. It comes as part of premium actually, only available in the premium SKU. It isn't available in the basic SKU. But basic SKU can be used for your dev and POC or sandboxing. Just make sure how do you want to replicate the functionality of Azure Firewall and want to replicate something with your existing vendor or someone who want to capture it, then it'll be great.
Wonderful. All right. Any other questions? All right. Sounds good. Well, so thanks for your time, Santosh. I'm just stopping the recording here.
All good, guys. Thank you. No worries. Again, thanks for the organizers to having me here, and have a nice day, guys. I'll just drop my LinkedIn here. If anyone wants to have any questions or something, you can connect me and ask your questions. I think I just done some 3 4 minutes justice again. Too early to the organizers to be keep me free. Thanks, guys. Thanks having me here.